Welcome back, everyone. We are now going to jump into a hands-on demonstration on creating custom routes in Azure. For this demonstration, we encourage you to follow along within the Azure Playgrounds, and we are going to provide a script which will build out an environment for you in advance. In this demonstration, we are going to start off with a virtual network with 2 subnets and virtual machines already created. This is the environment that will be built out by the provided script. And in our environment, we will have one subnet named NVA subnet, which is going to house a virtual appliance virtual machine. And we're going to have a second subnet named hub subnet 01, which will contain our virtual machines that we are going to apply a custom route to. Once our environment is built out, we are then going to create our custom routes by first creating a custom routes table, and then creating a custom route inside of that route table, which is going to direct all internet outbound traffic, or in other words, all zeros, through a network virtual appliance, which is populated by our virtual machine in the NVA subnet. And then after we create our custom route, we are then going to associate our hub subnet 01 subnet with that route table, which will then effectively force all internet outbound traffic through our virtual appliance then out to the internet. And then once that is complete, we are going to view the effective routes for our effective virtual machines just to confirm that our outbound traffic is indeed going through our virtual appliance. With that, let's go ahead and jump over to our Azure Playgrounds and get started. Okay, we are now in our Azure Playgrounds environment, and I have already run the script to go ahead and build out our environment shown by the previous slides. If you are following along, I would encourage you to go ahead and pause this video now, go into the PowerShell environment in Cloud Shell, and go ahead and run the script that will build out that environment as well. As a quick reminder, the text files that will give you the commands to copy and paste into PowerShell will be attached to the lesson resources, so you can easily copy and paste, wait a few minutes, and your environment will be built out. With that, let's go ahead and jump into the demonstration. Now, before we start creating custom routes, I want to start by viewing the default effective routes for our virtual machines before we apply any custom routes to it. To view the virtual machines in our resource group, let me go ahead and refresh my screen here. And we have the virtual machines that we created. And inside of here, we can see VM1 and VM2, which is in our subnet we are going to apply custom routes to. And we also have VM-NVA, which is our virtual appliance, which will be in our NVA-subnet. Let's go ahead and view the default effective routes with one of our virtual machines by clicking on VM1. And inside of VM1, to view effective routes, we need to view the network interface resource. Easiest way to get to there is to go to our networking tab on the left side underneath settings. And then in the top left, we have the network interface, which is attached to this virtual machine called VM-1 VMNIC. I'll go ahead and click on that. As that comes up, let me go ahead and zoom in just a little bit. There we go. And then underneath our network interface on the left side, if we scroll down to the bottom, underneath support and troubleshooting, we have our effective routes. And this is going to show all of the routes currently applied to the network interface for our virtual machine. And then after waiting about 10 seconds, all of our default routes come up. We actually have quite a bit, most of which are dropped addresses or dropped routes to reserved IP ranges. As we talked about in the initial lesson, when traffic is sent to some of these reserved IP prefix ranges that Azure has reserved, that traffic is just simply dropped. However, if we want to look at the ones that are relevant to us, we also have our internet route, which is currently going to 0000, and the next hop type is going directly to the internet. We want to change this by forcing all traffic through a virtual appliance, which is going to be accomplished by creating a custom route. Let's go ahead and do that now. However, before I do so, I need to verify the location of my virtual network before I create my route table. To check that, we'll go back to the overview for our network interface, and we can see that our interface is in a network in the West US location, which will need to mount our route table. Okay, so from here, our next step will be to create the route table. Easiest way to do so is go to our top search field, type in route tables, and we have route tables right here. And then we will click to create a route table. From here, we will fill out the typical information such as our resource group, which will be our playground resource group. Next step is to assign the region for the route table, which must match our virtual network. In this case, it is West US. Go ahead and scroll down and select West US, and then go ahead and give our route table a name. We'll just give it a super creative name of custom route table. Now, if this route table were to integrate with a virtual network or a virtual network gateway, we also have the option of propagating or duplicating those VPN routes in our route table. Since we do not have a virtual network gateway enabled, it really doesn't matter what we select here. However, for this demonstration, I'm going to go ahead and choose No to not propagate gateway routes. From here, we can go ahead and create our route table. There is no additional configuration we are concerned about for now. And then after validation, we'll go ahead and click Create. This will take just a moment to complete. I'll pause and come back when it is done. Okay, after about 10 or 15 seconds, our route table is up and running. Let's go ahead and go to our resource. And now that we are in our route table, it currently does not have any custom routes. Let's go ahead and create a new custom route so we can go ahead and populate it. Before we create our custom route, though, we need to go ahead and verify which internal IP address is being used by our network virtual appliance, which is going to be used as the next hop in our custom route. Let's go ahead and check that now before we come back to our route table. Let's go to our top search field, type in virtual machine. And I'm going to go ahead and backtrack here a little bit, go to our VM-NVA. And on the right side, we can see that our private IP address in the bottom right is 10.0.1.4. This is going to serve as the next hop location or the next hop IP address for our custom route. I'm going to go ahead and copy that. And now let's go ahead and go back to our route table so we can go ahead and create our custom route. Go back up top again, click on Route Tables. We have our custom route table we created right here. And now let's go ahead and create a new route in our route table. Let's go ahead and collapse this blade. And to do so, underneath Settings on the left side, we will click on Routes. From here, we'll go ahead and click on Add to make a new route. Let's go ahead and begin with a super creative name of Custom Internet Route. Next, we need to add in the address prefix. Again, from our previous discussions, the route to the public internet is all zeros, which will be 0.0.0.0/0. Next, we need to assign our next hop type. If we expand our drop-down menu, we have our 5 types here. We have a virtual network gateway used with VPN or ExpressRoute, virtual network for routing within the virtual network, internet hop for routing traffic directly to the internet, virtual appliance, which is what we're going to do, and we also have the none hop type to simply drop traffic to our range. In this case, we will go with a virtual appliance because we are routing it through a virtual appliance. Notice when we do so, we get an additional field called next hop address, and then in here, we will simply paste in our internal IP address for the virtual appliance we are going to route through. Notice that we get a prompt to ensure that we have IP forwarding enabled on our virtual appliance. Our startup script to build out our environment at the start of this demonstration does enable IP forwarding on our virtual appliance, so that step has already been created. However, that is a good key point to know that IP forwarding must be enabled on virtual appliances. Everything else looks good. Let's go ahead and click on OK. Now, at this point, we have a custom route added to our route table. However, it is not live or applied to any of our subnets until we associate that subnet with our custom route table. Let's go ahead and do that now. On the left side, underneath Settings, let's go ahead and click on Subnets. We'll click on the button to Associate. And from the drop-down menu, we will select our single virtual network called Cake Hub VNet. And then we have our 2 subnets, one called Hub Subnet 01 and the other called NVA Subnet. In this case, we are going to associate Hub Subnet 01 with our route to apply it to virtual machines inside of that subnet. Click on that, click on OK. And that's really all there is to it. Again, it's a pretty straightforward process. Create your route table, create custom routes, and then associate subnets with that custom route table. In my experience, it will take about 30 seconds for those routes to become fully live. In the meantime, let's go ahead and go to our virtual machines in our subnet, view the effective routes again, and see if all outbound internet traffic is now being directed through our virtual appliance. To do so, let's go back to one of our virtual machines. We'll go to our top search field, click on Virtual Machines. Let's go ahead and select VM1 again. We'll go ahead and check the effective routes on VM2 as well here in just a moment. Go to VM1. We need to go to the network interface card again, so we'll go to Networking. And then click on our network interface link right here. And then we will view the effective routes by once again going to the bottom left underneath Support and Troubleshooting and clicking on Effective Routes. And it may take about 10 seconds or so to bring up our routes again. Okay, and after about 10 seconds, we have our new effective routes. Notice that all of those dropped IP address hops are actually gone from here, And our only default routes is the default active route within the virtual network, or in other words, routing within the virtual network. And we also have our default internet route. Also notice that our default internet route that goes straight out to the internet has an invalid state assigned to it, whereas our user-defined or our custom route that goes out to the internet is the active one, which shows the next hop type of virtual appliance, the next hop IP address of 10.0.1.4, and it also shows the custom route name that is associated with that effective route as well, called custom internet route. And if we want to verify this applies to both virtual machines, we'll go back to virtual machines, click on VM2, go to networking, network interface, and then go to effective routes again, and that should be the exact same there. And then after about 10 seconds of waiting, we have the exact same output in which our default internet route is invalid because the user route, which conflicts with it, has a higher priority, and our user-defined outbound internet route is going through the virtual appliance, same next hop IP address, and the custom route name that is associated that makes that route active as well. Very good. So at this point, we've demonstrated the process of creating a route table, placing a custom route for outbound internet traffic in that route table, associating a subnet with that route table. From then, we were able to view the new effective routes for virtual machines inside of that subnet by viewing those effective routes inside of the network interface settings. Very good. Let's go ahead and review our key takeaways before we move on. Reviewing our key takeaways for a demonstration of creating and applying custom routes. We started in our demonstration environment by creating a route table and then creating a custom route inside of that route table. After our custom route was created, we then associated a subnet to that route table, and we were then able to view the end results of that subnet, or more specifically, the network interfaces inside of that subnet, by viewing the effective routes applied to it, from which we were able to observe that our custom route out to the internet was the one that became active, and our default internet bound route became disabled or invalid because the custom or user-defined route took priority. That's going to go ahead and wrap up this lesson. Let's go ahead and move on to the next one.